section 4.2 is titled Antiderivatives as Areas. In this section, we will look at how antiderivatives and areas are connected. Turns out that antiderivatives are really useful at finding areas underneath curves. So in example number 1, we're gonna basically kind of look at a basic situation where we use the graph to find the area underneath a curve. So in this problem, it says the velocity of a moving object is given by the function v of x, so the speed basically, is 15, where x is in hours and v is in miles per hour. So it seems like there's no x's in this equation, so that means that the velocity in this problem is always the same. It's always 15 miles per hour. No matter what time of the day it is, that's the velocity basically. So they're saying use geometry to find the area underneath the graph, which in this case, the area underneath the graph would be the distance that the object has traveled. So this is the XY plane, and we're going to be looking at part 1 first, where we are looking for the area under the graph during the first 3 hours. Now keep in mind that time is always positive, and in this case the velocity is 15. On the x-axis we're going to be putting time, which is in hours for this problem, and on the y-axis we're going to be putting the velocity, which is called v of x, and it's in miles per hour in this problem. Since velocity is constant and time cannot be negative, what we're going to get is a graph that looks sort of like this. So time cannot be negative, so therefore the graph does not cross into the y on this side, but it stays on the right side of the graph in the first quadrant, and it's always the same. That's the reason why it's staying kind of horizontal. So this tells me at time 0, the velocity is 15. After 1 hour, the velocity is 15. After 2 hours, same velocity forever. And in the first part of the problem, it says we want the area under this graph. Remember, this is the graph v of x equal to 15, between 0 and 3. So suppose 0 is right here and 3 is right there. We would like to know the area in this first rectangle, basically. So how much space is inside the rectangle? What we need to remember is the area of a rectangle is given by the length times the width. So the area of this yellow rectangle is the length of the rectangle multiplied by the width of the rectangle. Another way of saying that is to say multiply each side by the other side. So take one side of the rectangle, multiply it by the other side. So on this problem, how big is this side? Well, it goes from 0, it ends at 3. So the distance between the two numbers is 3. And on this side right here, the distance is from 0 to 15, that's 15. So turns out that the length is the longer one, we will call that 15, and the width in this problem is basically equal to 3. Okay, this is ugly written, so let's redo it. Width is equal to 3. And so at this point, we're just going to plug in the numbers, 15 for the length times 3 for the width, which is going to be 45. Okay, now keep in mind that this is area, and they told us in the problem that in this problem, the area under the graph is the distance that the object has traveled. So, if this is a car, it's basically how much distance this car has traveled. And it seems like the distance is 45, and it's in miles. So we're going to say a sentence at the end explaining what this means. It means that in the first 3 hours, we traveled 45 miles. So this is the reason why I'm going to go back into my calculation and write down over here distance. So in this case, the area of the rectangle represents the distance that our car or our object has traveled. That's the end of part 1, and the solution is basically 45 miles. So now the next part of the question says, well, what's the distance traveled, or what's the area under the curve between the 3rd hour and the 5th hour? So between x3 and x5. So let's redo the graph and figure out what the new calculation is going to look like. So this time around, our graph is a little bit different. Our rectangle is shifted a little bit more to the right, but again, the area that we're looking for is looking like an area of a rectangle, which means that we have to multiply the length by the width again. So in this case, what's the length and what's the width? So let's look at the graph. The distance between 3 and 5, how much space is there between the two? It's 2 units. And from the bottom to the top right there, it's basically from 0 on the x-axis to 15 on the y-axis. So that's basically 15 units. So again, we're going to multiply the length, which is 15, by the width, which is 2. And in this case, when we multiply 15 by 2, the answer is going to be turn out to be 30, and this is in miles. So between the 3rd hour and the 5th hour, we traveled 30 miles. So finally, we can say that the distance traveled between the 3rd and the 5th hour is 30 miles, and that's how the problem ends.